Today's learning intention is looking at maximum and minimum values. Our National 5 essential skills are solving trig equations and also drawing trig graphs. To calculate the maximum or minimum values of an expression of the form p cos x plus q sin x, we need to rewrite it as a single trig function, i.e. we need to use our wave function calculations. From National 5, we know that the maximum value of the sine and cosine function is 1 and the minimum is minus 1. Here are our graphs as a little reminder. If we were to sketch the function y equals 2 sine x, its maximum value would be 2 and its minimum value would be minus 2. Please remember the coefficient in front of sine or cos is called our amplitude, and that is the height of our wave. So if we have something in wave function form that looks like this, where we have root 2 cos 5x minus 45 degrees, this has a maximum value of root 2 and it has a minimum value of minus root 2. Example 1. Express 4 cos x minus 3 sin x in the form k cos of x minus a, where a lies between 0 and 360 degrees. And once we have done that, we need to then find the minimum value and then also state where it occurs. So starting by putting our expression in wave function form, we're going to expand k cos of x minus a and then rearrange so that we can compare our coefficients. So if I have 4 cos x minus 3 sin x, k cos a is in front of cos x, so that will give me 4. And k sin a is whatever's in front of sin x, and in this case will be minus 3. Please ensure you clearly state these. So k cos a is 4 and k sin a is minus 3. Using this information for our CAST diagram, cos a is positive, so cos is positive in A and C. Sin a is negative, so it's negative in T and C. So we're looking for our angle in the fourth quadrant. Writing out our rule, tan a is k sin a over k cos a. Tan a equal to negative 3 over 4. So inverse tan of 3 over 4 gives us 36.9. However, we need to take this away from 360 and our angle is 323.1 degrees. Finally, our value for k, 4 squared plus negative 3 squared, will give us an answer of root 25, so k is 5. So the first part of the question asked us to express 4 cos x minus 3 sin x in the form k cos of x minus a. So that gives us an answer of 5 cos of x minus 323.1 degrees. Now the second part of the question asks us to find the minimum value and where it occurs. So if we have a think about the minimum value of 5 cos of x minus 323.1 degrees, if our amplitude is 5, that means our minimum value must be minus 5. So to find where this graph is equal to minus 5, we must equate 5 cos of x minus 323.1 degrees equate it to minus 5, and then solve the trig equation. So continuing our solution, we've equated our wave function to minus 5. We then need to rearrange to have cos on its own, so we're going to take the 5 at the front over and divide. So cos of x minus 323.1 degrees is equal to negative 1. So now we need to really find the inverse cos of minus 1. You can do this without using a calculator or your CAST cost diagram because technically you should memorise your cost graph. And looking at our cost graph here, we can clearly see that it hits -1 at 180 degrees. Therefore, x minus 323.1 degrees equals 180. So to find x, I need to take 323.1 degrees over and add it on to 180. This will give me an answer of 503.1 degrees. Now, this answer might seem a little strange as 503.1 degrees does not lie within our range between 0 and 360. Therefore, that must be the second time, or if we were to draw a second wave, that is exactly where the graph would hit its minimum. So to find where the first wave would hit its minimum, we need to take away 360 degrees, a full wave. So the minimum value occurs 503.1. If we take away 360, will give us an answer of 143.1 degrees. So the minimum value has a coordinate of 143.1 degrees minus 5. Example 2. Express sin x minus cos x in the form k cos of x minus a, where this time a lies between 0 and 2 pi. And now we have to look for the maximum value and find where it occurs. So first starting with our compound angle expansion and then flipping round our cos A cos x sin A sin x, this will enable us to then compare coefficients. So again, be very careful comparing your coefficients. K cos A is in front of cos x, so in this case it will be equal to -1. And K sin A is in front of sin x, this time it will be +1. And here we can clearly state it. Using this information, we can draw our cast diagram. So cos A is equal to a negative value, so cos is negative in S and T, and sin A is equal to a positive value, and sin is positive in S and A. Therefore, in this occasion, we are looking for an angle in our second quadrant. Next step, we're going to write out our rule. Tan A equals K sin A over K cos A. Therefore, tan A equals -1 over 1. Now remember, the negative just lets us know the quadrant in which it lies, so we're really looking for inverse tan of 1. And that would be 45 degrees using our exact value triangles, or we need to change this into radians because we're dealing with A between 0 and 2 pi. So 45 degrees is written as pi over 4. However, that's not the angle that's in the second quadrant. We need to take pi over 4 away from pi, so angle A is actually 3 pi over 4. If we were to write that in degrees, it would be 135 degrees. Now to find the value of k, square root of 1 squared plus -1 squared, so k is equal to √2. So now we can clearly say sin x minus cos x in wave function form, and the answer is √2 cos of x minus 3 pi over 4. Now the second part of the question this time asks for the maximum value and where it occurs. The maximum value of this graph is going to be √2. And to find where it occurs, we must equate the wave function to √2 and then solve the equation. So if we continue our solution, √2 cos of x minus 3 pi over 4 is equal to √2. And again, I need to rearrange this to have cos on its own. So I'm going to take my √2 at the front over and divide, and we'll find I have cos of x minus 3 pi over 4 equal to 1. So we need to again think about our cosine graph, and we need to think about when is it equal to 1, when is it equal to its maximum. So having a look here, we can see it's clearly equal to its maximum at 0, but also 2 pi. So we can write x minus 3 pi over 4 is equal to 0 and also 2 pi. But to find the value of x, we need to take our minus 3 pi over 4 over and add. So x is equal to 0 plus 3 pi over 4 and 2 pi plus 3 pi over 4. However, this second angle is out with our range, so we must eliminate it. Therefore, we can clearly see our maximum value x occurs when we at 3 pi over 4. So our maximum value, of root 2 applies when x is 3 pi over 4. And we need to state this clearly as a coordinate point, the maximum value being 3 pi over 4 root 2. Now try these examples on your own. Please pause the video. And the answer? The maximum value of the graph was root 17, and that occurs when x is 1.326. And the minimum value would be negative root 17, and that occurs when x equals 4.468. For extra practice, please turn to page 316, exercise 16G. Today we've learned how to find the maximum and minimum value of a wave function. We need to do it by following these steps. Put the expression into wave function form. We then need to state what the maximum or minimum value is. We need to then create an equation to find the maximum or minimum value, basically equate the wave function to it. We solve to find the x coordinate, and then we finally clearly state our coordinate point.